Greetings. Today we are going to solve this question paper from Limpopo, which is an assignment from grade 10. So we are going to deal with trigonometry, which are functions, and we are also going to deal with analytical, and also to solve for x and other things which are attached here. So now when we go to our first question here, which is question 1. So it's gonna show that is it parallel to, okay, let me first see if this is live first. Okay, yeah, it's live now. So now our first question is, use this diagram below to prove that the opposite sides are opposite side of a parallelogram are equal. So Apanoni, so here we are going to prove using congruency. So that's the most important thing. We are going to prove here using congruency to show how the opposite sides are of a parallelogram are equal. Which are the opposite sides? Is this? These are the opposite sides, and let me use another pen. And also here are the other opposite sides of a parallelogram. And then now let's go deeper to prove congruency. So you have to first study and know that what are the characteristics of proving congruency. So a characteristics, the first one is to if we have two sides of a triangle and an included angle, they are equal. And the one that we are going to use here to prove congruency, it's when they share a common side or they share a side, and on that very same side that is equal on two opposite triangles. For example, let me draw two triangles to give you an example of what I am talking about. Okay, so when we come to this one, these are the two triangles here. So if in these two triangles here we see that these two angles are equal, or maybe they share two triangles, and then the common side here of these opposite triangles are equal, that's how we'll prove congruency. So we are going to also apply it here. So now when we apply the very same rule here, so now we are going to say in parallelogram, this is the sign of parallelogram. We write it like that, in parallelogram PQSR. That is the parallelogram there. So now we have to prove which side is common. If we check on these two triangles, we are dealing with triangle PRS and triangle PQS. So now with these two triangles that we are dealing with here, in triangle PRS and triangle PQS. So now in these two triangles, they have a common side. PS equals to what? PS. What is the reason? Common. So now we just have to prove that two angles are equal now. Which two angles are equal in this triangle? First, we have to use alternate or cointorial angles, because these two, we are given that these lines are parallel now. Now, if we come here, we are going to say that this angle here, which is angle P1, and also angle S2, they are equal. The reason is what? Is alternate angles are equal. But we have to say, why are we concluding that, given that which parallel lines are we dealing with? We are dealing with parallel lines RP and also QS. Given that RP is parallel to what? QS. And then another set of angles which are parallel. Let me change the color here. We're using different parallel lines now. We are going to use these alternate angles here, which is going to be which is going to be angle P2. This is this angle which is within the Z here, and the angle S1, and then the angle S1 are equal. Reason equals to alternate angles are equal. And then we are given what? We are given the parallel lines. Given PQ equals to what? Given PQ is parallel to rs. And therefore, because we have proved these characteristics, it means these two triangles are congruent. PRS is congruent to PQS, meaning that that's when we can conclude that, okay, the opposite sides are equal. PQ equals to RS, and then another thing which, well, the reason is congruency here. Another thing that we can also do here, okay, let me increase the volume. I see here it's saying that the volume is not that audible. Let me increase the volume of my mic. Let me increase the volume of my mic. Okay, so now I hope I'm audible. If I'm not audible enough, after this you can say in the chat, and then I will see what I can do. And then now, or you can say PQ equals to RS, or you can say PR equals to QS. The reason also here is congruency. So now when we go down here, and now when we go down here, it says we must find the angle of the size of E. Oh, but now we are going to this question next. Let me wrap here so that we can work. So that is the reason for the first question. Let me wrap here. So now when we go to the first question, second question, it says that in the diagram below, ABC is a parallelogram with 9x plus 12 and also f 5x minus 24. So an important thing that you have to know about the parallelogram is that opposite angles are equal. Opposite angles are equal. That's what you have to know in a parallelogram. And we are given this to say that 15x minus 24. And then here we are given 9x plus 12. So now we are given the values of opposite angles. So it's just like a hint of saying that we must use a theorem or a principle that in parallelograms involves opposite angles. So now when we come here, we are going to say in parallelogram a or it's not A B C D, but here they wrote A B C D, but it's supposed to be E F G H in the way that they have put it down here. So now angle F and also angle G there will be angles which are equal. Opposite angles of a parallelogram are equal. Another thing that you have to know is that how exactly do you write this equality? How do you reason here? So I managed to put the exam guideline on this other side so that we can also know how to reason, but it is also shown on your textbooks on how you reason. But if you check the exam guideline here, let's check where it talks about opposite angles of a parallelogram are equal. So opposite angles of a parallelogram are equal. Here is it. And the way that you reason it, it's either you put this long one or you can just reason it like this in a short way. So you must always know how to reason in maths. They don't only want to know that you caught the fish, but they need to know how you caught the fish. So it's opposite angles of a parallelogram. You write it like that. So now we are going to come and write it that opposite angles of a parallelogram. So that's how we write it. And then now we must not forget, why are we writing all this? We are calculating the value of x. Now wherever we see f, we must put what f represent. We must put the value of x, and then we say 24 degrees. And then now this other side where we see g, we must write the value of g, which is what, 12 degrees. And then we say, and now we solve for x. Let's combine common factors. It's going to be 5x minus 9x. And then now this side is going to be 24. It's going to be 12 plus 24. And then now when you do maths, it's gonna say 15 minus 6, which is gonna give you 6x, and then 12 plus 24, which is gonna give you 36. You divide both sides by 6, you divide both sides by 6, and then our x will be equals to 6. So here we have found the value of x. We have found the value of x, so our x equals to 6. Let me put it here, that our x equals to 6. If you have any question, you can say in the chat, and then if you do not understand, you can say in the chat, and then I will explain to you. So now let's proceed to the following question. Let me wrap here. So when I proceed to the following question, so now it says that you must calculate E. You must calculate the value of E. So another thing that you may have to know, which is very much important, is that after we have solved this, we must substitute so that we can get the exact value, so that we can get the exact value of F, so that we can get the exact value of G. And then we come and substitute here. We got 6, and then we say minus 24, and then let me press in my calculator. 15 times 6 minus 24 is 66 degrees. And then here you can either choose to do it manually, or you can just know that opposite angles are equal, which will just lead to 66 also. But you can just write it if you want to verify whether the way that we are doing it is correct. It also gives us 66 degrees. So here we have gotten our F, we have gotten our G. Now they want our E, and we have never worked with E. How do we even get to E? There's another important principle that we have to use here in order to get our E, is to say that angle E, sum of angles of a quadrilateral, give us how much. If you know it, you can say in the chat to say that what is the sum of angles of a quadrilateral, and then it says G, and then it says H also, and then now they are going to give us a 360. That sum of angles of a quadrilateral give us 360. But this is not a quadrilateral only, it is a parallelogram. But you have to know that anything that has 4 sides, if you add all the angles, you'll get 360. So now if you go to the if you go to the exam guideline, it will teach you how you reason for this, of that sum of angles of the quadrilateral will give you 360. It says that you write it like that, sum of angles in a quad. So you have to always know how to reason. It's very much important for you to know how to reason. That's why I am emphasizing it, sum of angles in a quad. So that's how we do it. So now we have two unknowns here in this equation. We have two unknowns. Let me lay them down clearly. Where we see F, we are going to write 66 degrees because we solved it there, and then where we see G, we are going to write 66 degrees because we solved it there. But we have two unknowns, and that's the problem. We cannot solve two unknowns in one equation unless we are doing simultaneous or something. So now how we are looking for E, which means that E we have to keep it. But what do we do with H? What do we do with H? But a good thing that we also have to apply is that because these are opposite angles of a parallelogram, E and H are equal. E and H are equal because they are opposite angles of a what? Of a parallelogram. It means that where you see H, you can put E, which means that here we can just come and substitute here and say plus 66 degrees, and then plus what? Plus E. And then we say 360 degrees, and then we say 2E equals to plus 66 degrees, and then we say plus 66 degrees again equals to 360, and then we come and do our maths now. So we are just going to take the numbers that side, and then it's going to be 360 degrees minus 66 minus 66. So I am touching the things on the side, it's ending up moving my slides. And then now it's like that. We divide both sides by 2. We divide both sides by 2 so that these 2 cancel 2. We are left with E. E equals to, let me press it, 360 minus 66 minus 66 over 2. And then it's going to say 114 degrees. So here we got that our E equals to 114 degrees. 114 degrees. So if you have any question, you can say. If you do not understand something that I wrote, you can say, and then I will explain it. So but this is what we got so far. Just want to wrap this. So now let's go to the the following question. It says that in the diagram below, so it's just mentioning what has been listed down there. Now let's go down there and see what has been listed. And then now when we come here, it says that determine the coordinates of M, the midpoint of line NZ. Let me drink some water. So now it says that determine the midpoint of line NZ. So from line NZ, let me increase this so that we see clearly. So from line NZ is the imaginary line that you draw here. Imaginary line. So they're saying find the midpoint of this line. It might be somewhere here. So you have to know the formula of calculating the midpoint. Midpoint is just like you bring in what you have and your friend brings in what they have, and then you add them up and then you divide them by 2. So now this variable or this coordinate is going to bring its x, and also all of them they're going to bring its y, and then after we divide both of them by 2. So that's what we are doing here in the midpoint. Everyone is bringing what they have, and then we take that and divide it by 2. So when we check what the x is, like saying minus 6 plus here, and then we come and say at the x plus 5, and then divided by 2, and then the y is minus 6 also, and then the y will come and say minus 3 plus minus 3, and then we divide both sides by 2. And then here we say this we just press in the calculator, -5, -6, is it negative? Yeah, -6 plus 5 over 2, and then it comes and say -0.5, and then this side is coming. It says -6 plus minus 3, and then it comes and gives us -4.5. So this is the midpoint here. So the midpoint here is going to be negative 0.5 and also -4.5. So that's our midpoint from there to there. So another thing that's very much important in the midpoint of a parallelogram is that the midpoints dissect one another if this is a parallelogram. But right now we haven't heard that this is a parallelogram, so we can just continue with the following question. Now we are just seeing a quadrilateral so far, and then 5, and then when it continues, it says that calculate the gradient of the line NT. The gradient of the line NT. Now we are dealing with this line here. We want its gradient. So we have to know the formula for calculating the gradient. We want the formula for calculating the gradient. Let me erase here. So the formula for calculating the gradient is m equals to y2 minus y1 over x2 minus x1. That's the formula for calculating the gradient. And then I come and we now each variable is going to bring its x, and each variable is going to bring its y. So now we are dealing with these two. So the y is -6 of n, and then minus the y of t, it's 0, and then the y of n is -6, and then the x, or the x is 3. So now it's just this. Just pressing the calculator is gonna be 2 over 3. It's gonna be 2 over 3. Is it 2 over 3? 2 over 3. 2 over 3. Yeah, it's gonna be 2 over 3. So yeah, I did it by the head. That's why I was contemplating. So the gradient is that of line NT. So now, when we continue with that, it says that prove that NT is perpendicular to TW. So now we have to prove that these two lines are perpendicular. So now, when we prove that these two lines are perpendicular, let me wrap this so that we can see clearly or which two lines are they talking about, and then how do we prove that whether these two lines are perpendicular. So our TW is an imaginary line from here to here. So they want us to prove that NT, our NT is this one, and then our TW is this one. So they want to prove that this angle is a right angle. We have to find a way to prove that the angle between here is a right angle. So a way that you can prove that two lines are perpendicular, it's by a negative reciprocal. It's when the product of those two lines gradient, they give you -1. If you take two lines, for example, if these two lines that we are given here are perpendicular, it means that the gradient or the m of line NT multiplied by the m of line TW is gonna be -1. So we have to prove, find the two gradients and multiply them, and we get -1. It will prove whether these two lines are perpendicular or not. But now we have the gradient of another line. We have the gradient of line NT, which we just calculated. It is what is 2/3. It means that we have to find the gradient here, which when we multiply it by this, it will give us -1 this side. So now let's get the gradient of TW. If we get the gradient of TW and we multiply it by there, that's when it will give us the right answer. So now here we had gotten a coordinate this side. We had gotten a coordinate this side, and the coordinate that we had gotten here at first, it was this one. Let me just write it here. We must write it this one. So this is the coordinate of here, which tells us that because this coordinate, we had gotten it as a midpoint of this. So these two midpoints are going to dissect. So because these two midpoints are going to dissect, it means that now this coordinate of NZ, which is here, of the midpoint of Z, it will be also a coordinate of this line. Will also be a coordinate of this line, which means that now we can come and use the gradient formula of y2 minus y1 over x2 minus x1. And then now when we come here, add our y is gonna be 0 minus -4.5, and then when it comes to our x is gonna be the one that we started with here, we must also start with there. It's gonna be 3 minus -0.5. And then when we come here, we have to solve for our gradient here. So we just come and say 0 plus 4.5 over 3. The reason why I'm saying plus is that negative times negative is positive, and then we multiply there and we get 9/7. So now if we get 9/7, when we multiply it 2/3 multiplied by 9/7, it has to give us -1 if these two lines are perpendicular. So now we are going to say 2/3 and then we come and write it there times 9/7, and then it gives us 6/7, and then it didn't give us -1. And we must know that because this one 6/7 is not equals to -1, it means that NT is not perpendicular. It means that NT is not perpendicular to TW, which means that here there might be a typo or something, because these two lines are proving that they are not perpendicular to one another. And then they say that if NTWZ is a parallelogram, it says that, okay, now the conclusion here just gonna be the conclusion here is just gonna be that NT is not perpendicular, or not perpendicular to and is not perpendicular to TW. The reason will be that 6/7 is not equals to -1, because it's supposed to give us -1 if these two are perpendicular. So now if you have a question, you can say in the chat. If you don't have a question, we can continue. If I do like this, I'll wrap even the things that I still need. So now let me cancel, let me wrap this so that we can continue working. So it says that if NTW is a parallelogram, determine the value of x and y. So that's something which is very important to say, that determine the value of x and y, because we have been having this unknown ever since. So now we have to get them now. So if we see that this is a parallelogram, what do we know about a parallelogram is that the two diagonals of the parallelogram, they bisect one another. What does that mean? It means they cut one another into two equal parts, that this part is equal to this part, and also this part is equal to this part. That's what we must know when we come to deal with this, meaning that from year to year, or let me use another color so that I can demonstrate it well, meaning that from year to year is the midpoint from year to year. That's the midpoint. It's the midpoint, meaning that we can use the midpoint theorem because we have this coordinate, but we don't have this. But in the one in the middle, we have it. So now we are going to use the midpoint theorem going backwards. So now we are going to say m, which is the midpoint, equals to x1 plus x2 divided by 2, and then we come and say y1 plus y2 divided by 2. Now, but we are going to use it going backwards because we know the midpoint, but we are going to x. We are going back. So let's make this our x1 and then make this our x2, and then we solve going down. So if we make that our x1 and we make the other one our x2, so now let's start substituting now. X1, our x1 is this x, is x, and then when we come to our x2 is just 3 up there divided by 2, but what is our midpoint coordinate here for x is going to be 0.5, and then we come at our y. What is our y1? Is our y there, the one that we are looking for, plus what's our y2? Our y2 is going to be 0 there, and then we just divide it by 2, and then we equate it. What are we equating with this midpoint here, which is -4.5? Because as I said, why am I using this coordinate? I will explain again to say that I'm using this coordinate again because the midpoint that we got for line NZ, because these two diagonals bisect one another, it will be the same midpoint for this line. So that's why I'm using this coordinate here. So now we just have to do maths where we just make the subject the formula x, and then both sides I'm going to multiply by 2, and then I multiply by 2, so that this 2 cancels this. Is going to be left with x plus 3 this side, and then it's going to be equals to -1, and then this side I will be left with multiply both sides by 2, multiply both sides by 2, and then it's going to just be when you multiply both sides by 2, this is going to cancel this. It's going to be y plus 0, which is like we can add a number by 0, it is that number, and then 4.5 multiplied by 2. 4.5 multiplied by 2, how much? It's 9. So yeah, that's very much important. And then this y is 9, and then we get to that this side we get x equals to negative what's that, -4, y and -4. So now our point will be -4 and 9. So let's see if it they say that here our x is equals to what? Oh, here I left out this sign. It's very much important. And I will also show you how I know that I left it. It's because the y is negative. y is going to be negative and x is going to be negative because they're this side at the Cartesian plane. But the way the way that I saw that I left a negative. Which negative did I leave? This negative multiplied by a positive is going to give us a what? A negative answer. 4.5 multiplied by 2 is going to give us a what? A negative answer, because this one is negative. So that's also how I knew that I had left a sign, because it also has to make sense on the graph. What you calculate is going to be negative 9, and then this side we got negative 4. So now the coordinates correlate to what is written there. So though the coordinates are negative 4 and negative 9. So now when we go to the following one, now we are going to question 3. If you have a question, you can say it in the chat, and then the questions I will try to address them. So now when we go to the second one, when we go to the following one, it says that the equation f is a straight line that has the following coordinates, which are a, and then it's gonna say equals to a which is negative 2 and 4, and b which is 2 and 0 respectively. Draw a neat graph of f indicating the coordinates a and b on the graph labeled the graph f. So now we are drawing a graph. So me, I will make a sketch. You have to draw it nice using a graph and using a ruler and a rubber, so that they can give you nice marks there, so that your work is presentable. But me, I'm just gonna do a rough sketch, but I'll make sure to indicate whatever that they want us to indicate here. So now when we draw our Cartesian plane, this is our y-axis, and then this is our x-axis. So this is our y, is our x. So now I'm just gonna indicate here 0. 0 is for both. 0 is in the beginning. I say 1, 2, 3, 4, 5. Then I say 1, 2, 3, 4, 5. Then I say 1, 2, 3, 4, 5. You must use a ruler, and then 1, 2, 3, 4, 5. Then know that these sides they are negative, this side they are negative, and then you are done with drawing it. And then now we come and plot now. Our a is when x is negative 2. So let's draw a line here. Let me just use this dashed line here to say that it's when x is negative 2, and then there's our negative 2, and then where y is 4, there's our 4 there, there's our 4 there. Yeah, so now this is the point here. We just come and draw this point here. And then now the second thing, our b is where x is 2. So now where x is 2 is here, and then our y is where y is 0. We just come and say 0 here. So let me just use the red also, because I've been using red. And then now we just come and make sure that you draw a straight line that goes through those 2 points. Yeah, that's not a straight line, but you get the gist of it, of how a straight line has to be. And then now let me just wrap this, because these are for you to be able to draw. They are not for the marker. The marker doesn't have to see these lines. Of course, they are called constructing lines. So after you draw these constructing lines, you just wrap those lines, and then they say indicate the coordinate. This is very much important. So you say this is a is negative 2 and 4, and then this is b. This point is 2 and 0. So that's very much important. And then they say that determine the equation of f. So the equation of f. So now we have to find our equation. So our equation is y equals to mx plus c. That's our equation. But you must always note that the c is equals to the y-intercept. So where the graph intercepts here, where the graph intercept is your c. If you can check clearly, if you draw your graph to scale, here is gonna give you the exact number. If your graph is drawn using a ruler and perfectly, you're gonna get your c here. But when I estimate here, I see that the c is almost 2. C is almost 2. Let's check if the calculation will prove that. If our c is almost true, let's use the calculation to see that will it be correct now. And then we say m equals to y2 minus y1 over x2 over minus x1. Our m is the gradient. So now we use the two coordinates that we have been given there. Our two coordinates that we have been given is at y we have been given 4 minus 0, and at x we have been given a negative 2, and then a negative 2, a minus sorry, and 2. Yeah, I almost miswrote them there. That's why I was checking and confirming that is that correct. Negative 2 minus 2, and then it's gonna just give us negative 1. So we got that is this is negative 1 here. If here we got negative 1, let's prove our c now. Our m equals to negative 1. Now let's work out our c. Our c, we just take any equation, we just substitute. So now we have y equals to negative 1 x plus c. So we just take any equation, we substitute. Let's take the one with 2 and 4. We just come and put 4 here, and then into negative 1, in place of x we put negative 2 and plus c, and then now we put all those that side, and then if this multiplied by this is gonna give us positive 2, and then when it comes this is gonna be negative, and then it's gonna be c, and then our c equals to 2. You see, we got our c equals to 2. And then what did we say from the graph? In the graph it shows you the estimate, but if you drew your graph to scale, you are going to see that, oh, your c is actually 2. That's why we said it up here that that's the y-intercept, that we see it by what? By checking on the graph if the graph is to scale. So now our equation is y equals to negative 1 x plus 2. So that's our graph there. So now let's go to the following question. If you have any question, you can say, if you're understanding, you can give it a like. And then it says that a straight line G is perpendicular passing through point A. Calculate the x-intercept of G. So there's another line here. Let me use another color to draw this imaginary line. So they say it's perpendicular. So it's something like this. So perpendicular like this. Yeah. So perpendicular, it means that it forms 90 degrees here, and it passes through this point A. So this line is here, and it's perpendicular there. So this is another graph that they say it's being drawn here. So this graph here, we are told that it's graph G. So now what are we told about this graph G? They were told that it passes through point A. It means that they share a point. Another thing, they said the straight line is perpendicular to what? To A. So now I say that calculate the x-intercept. So they want to know this point here, to say what is this point that this graph touches the x-intercept. We wanna know. But what we can know from the graph, if the graph is drawn according to scale, it means that the answer is going to be less than negative 5. It means that negative 6 going that side if the graph is drawn to scale. So now this is it. So now let's go and see if how to calculate this x-intercept, which is less than negative 6. So now let me wrap this so that we can work. Let me not wrap the graph because the graph is important. Let me just wrap this. And you must remember that equation here of y equals to negative 1x plus 2. So now we are going to find the x-intercept here. So now you must know that you must start by finding the m. You must first start by finding the gradient. Now there are not 2 points on this line. You cannot find the m using the normal sense, because what? There are no 2 coordinates. So now finding the m is going to use that equation that we discussed earlier, that 2 gradients that are perpendicular, they will give you the product of negative 1. They will give you the product of negative 1. Let's see if that is so now we are going to see here. We are told that they are perpendicular. So now we are just going to substitute here. This is the gradient of this first graph, and then the gradient of the second graph, it's m, and then it's going to give us negative 1, and then we solve for m, and then m is just gonna be positive 1. So we got the new gradient to be 1. So, and then this new gradient, which is 1, is going, its equation is going to be y equals to 1 x plus, we don't know c. So now we have to look for the c. But what do we know about this equation? We know that it has a coordinate of a, because they say that it passes through a, meaning that you can substitute a to find the answer, meaning that you can come and say 4 into 1, a is negative 2 plus c, and then let's see how much our c is. It's going to be negative 2, and then it is going to be 4, and then it's going to be this, and then when this comes this side, it's going to be this is going to come this side, and then it's going to be a 6, here it's going to be 6. When it comes this side, our c equals to 6. So here what we are getting about our c is that we are getting that our c is 6. What's our c? We must know that our c is our y-intercept. So it means that this graph here is if it's going to go up and intersect here at what? At 6. So this 6 is here. Not that it makes sense because it's greater than 5 here. It makes sense to find that c, because I had said earlier that what our c is our y-intercept. You must always keep that in mind. But we are not looking for this. We are just looking for the equation now. So we are saying our equation is full now. It's going to be 1x plus 6. Now let's substitute now. They are looking for the x-intercept. Always when they look for the x-intercept, y equals to 0. So now when it comes to y, we put 0, and then we come and say on our x, we come and put we are solving for x now, plus 6, and then our x is negative 6. We just put the 6 that side. As I said earlier, that our x is going to start from negative 5 going that side, and from negative side going that side is negative 6, and we get our x getting as negative 6, which makes sense from the graph also, which means our x equals to what? Negative 6. That's our x-intercept. That's where our x-intercept. So you can write it as a coordinate. You can say negative 6 and 0, because at the x-intercept, y equals to 0. So that's how we solve that one. If you have any question, you can say, but if you don't have any question, we shall continue. So now I can wrap everything, because now we are in the final question. So now let me drink some water. Talking a lot makes me have a dry mouth. So now in this graph, you are given the following, which are just shown in the graph. We'll just see them as we go. And then when we continue, see that determine the range of k. What is a range? A range is all possible y values. So in this graph, which are the possible y values? As you can see that this graph is facing down, is frowning. What do you know about a frowning graph? The a is negative, meaning that if they ask you to solve for this a will be negative. That's the first thing that you must know about the frowning graph. And the thing that you must know about the frowning graph is that its turning point will be its highest value. You must first get its turning point. What is turning point here? Its turning point is 0. So it means that 0 is its highest value, and now the graph is found where the graph is going to be found less than 0. So now it means that the 0 is the maximum here, and then we're gonna say the graph is equal or less than 0, and then our graph is k of x. So those are the possible possible y values. The graph is found less or equals to 0. So it starts at 0 and goes down. So it means that we can go to negative 50, negative what, up until infinity. Some will say like this, but this is still the same. Some will put it like this to say that and then equals to negative infinity. Still the same thing, because it means that it goes until and until and until. And then now some will use coordinates and say that it ranges from y. These are the coordinates of y. The first one, or the one which is the least, is from negative infinity until up until what? 0. the biggest one is 0, the smallest one is infinity. So you can choose either way to write the domain, just to show that what are the possible y values. What is the domain? The possible x values of the graph. If you check this, they say the domain of the graph of P now. This is the graph of P, this straight line. So the x are going. They're not stopping. That's why there's an arrow. And then the x are going more negative there. And this arrow means that they are continuing like that, meaning that this from negative infinity to positive infinity. There is no stop in here. Or you can just write, or if you want to write it like this, you can just come and say x is equal or greater than positive infinity is equal or greater than this. You can just come and say it like this. So it's up to you, negative infinity. So now let's go to the following question. Now, when we go to the following question, it says that 4.3, given that the gradient of AD, this line, it's 1, determine the equation of AD in the form of P equals to x mx plus c. So now let's check. We have the gradient y equals to mx plus c. So now in the form of the gradient, we put what? 1 x plus c. And then what do we know? C is the y-intercept. It means that because here we see the point of the y-intercept, c will be what? Negative 6. We can just come and say c equals to 1 x minus 6, and then we are done. But they will give you 1 mark if you do this. You have to show how you got it. You have to show how you got it. They need you to work out this c. How are you going to work out this c? You're just gonna substitute. Let's take it from here and then substitute and solve our c and see what's our c here. We substitute here and come and put this point A, and then we where we see y, we put 0, and then we say 1 into 6, and then we say plus c, and then we just come and say c equals to negative 6. We solve our c, and then when we solve our c, which is that negative 6 that we solved up there, is 1 equals 1x minus 6. Then therefore this is our answer here, 1x minus 6. If you don't want, you can choose not to write the 1. It's up to you. And then now when you go to the 4.4, it says that determine the equation of k in the form of ax squared if b is the equidistance from a to c. So now let's see how we are going to solve this. So now we are determining this one, that we have determined that because the graph is frowning, it has to be negative. But if the graph was excited or smiling, it was going to be positive. So now we're going to solve this a, and then we just write this equation as is. Now we have to find 1 point. We have to find 1 point in the graph, and if we find 1 point in the graph, we'll be able to just substitute it here, and then we just find our answer straight away. But what is that point? Because we are not given any point, it means that that point we have to work it out. We have to work out that point. So now let's go down. Now when we come to this point here, to working out this point, we are going to say we are even told that there is an equidistance. What is equidistance? It means that B is the midpoint. That's what they're telling. B is the midpoint of C and A. And every time you hear about midpoint, you must think of the midpoint formula to say that now you can use the midpoint formula to find B, which is the coordinate of this. And then now you can just substitute that B. So the first procedure, find B. And then when we find B, we continue from that B and substitute it here and find our A, and then we find this equation. So what is our B there? It's midpoint of saying a B equals to our x1 plus x2 over 2 into y1 plus y2 over 2, and then we just come and take these 2 points, and then we just come and say, what is our x? Our x is going to be 0 plus, and then what, 6, and then divided by 2, and then here we at our y is going to be negative what, negative 6 plus negative 6 plus 0, then we say 2, and then we just come and write the coordinates here. It's going to be 6 divided by 2 is going to be 3, 6 divided by 2 is going to be 3, negative 3. So this is the point here. Let's see if it makes sense in accordance to the graph. When we check the x, if we check here on the graph here, we'll see that the x is on the positive side. So the x is on the 3, and then the y is on the negative side. It's below the Cartesian plane. It's going to be on the negative 3. So it makes sense. So you must also rectify and check if the thing makes sense on the graph also. So now, but know that we're not asked to find the b only, but we are going to use the b to substitute it at k at x, and then solve our a at x. So now we can come and just substitute that b at x, put at y we put negative 3, at x we are going to substitute 3, and then we square, and then it's going to be 9 divided by 3. So let me just not brush, and then it's going to be that divided by 3 divided by 3, but divided by negative 3. It's going to be a equals to 3a. Is it going to be 3a? Yeah, it's going to be 3. So this divided by this is going to be negative, though. It's going to be negative 3a. That's how it's going to be, but the a is gonna cancel. So because this side is gonna be left with a, yeah. So let me just do it clearly. I see even my let me just do it. I'll sharp them later, and then this side is gonna be 3a. This side is gonna be 3a. This side is gonna be 1. But this side is gonna be negative. We divide both sides by what? By negative 3. We divide both sides by negative 3. Our a equals to 1 over 3. That's our a there, negative 1 over 3. So now when we write our equation, it's going to be k at x equals to 1 over 3 over what? Over x squared. So that's our equation there. Let me write it here. So negative 1 over 3 x squared. So there is it. So now the coordinates of d. Let's find the coordinates of d now. The coordinates of d, let me first wrap this so that we can use this space to find the coordinates of d. Let me also wrap this also. What do we know about d? D is where these two graphs meet. You see this graph and this graph, they meet at D, which means that they have a common point there where we the D in the graph. For example, if we check the graph of k at x here, let's put the graph of k at x here. This is where the graph of k at x is equal to the graph of p at x. They are equal there, meaning that the dy there is equals to the dy here, meaning that because that's where the graph are equal here, they are the same, they have the same coordinate, which is d, meaning that because y here is p at x is equals to this, you can just come and say put p at x here, and then because there k at x is equals to this, negative 1 over 3 x squared is equals to this, and then you solve for x, and then what will be your x? Your x will be your x coordinate of d there. It will be your x coordinate of d, and then now you just have to use a trinomial. So you kick that side, you kick it that side so that it can be positive. Then you can say 1 over 3 x squared plus what? Plus 1 x minus 6. And then you must try by all means not to work with fraction. So that's why I choose and it's more preferable to multiply by this, so that this 3 cancels this, and then it's gonna also multiply all this according to the factors which are there. So it's gonna be x squared plus 3x, and then this minus 18. So now we are going to use what? We are going to use this method. We are going to use this method, factorization. So now, how do we factorize? We check the factors of 18, which are the numbers that you multiply them and they give you 18. The first one is 1 and 18. The second one is, you must account for the negative also. I'll explain how you see whether it's positive or negative later. And then the other numbers is 2 and what? And 9. The other numbers is 3 and 6. Those are all the numbers that you multiply them and they give you 18. So now you have to find the factors of 18 that when you subtract them, they give you the middle number. If you subtract 18 minus 1, does it give you 3? No. If you subtract 9 and 2, does it give you 3? No. If you subtract 3 and 6, does it give you 3? Yes. It means that these are the factors we are using. So how do we choose the sign? It means that here is 3, here is 6. We are using 3 and 6. So how do we find the sign? These factors, they must be in a way that if you multiply them, if you multiply them, they give you this, and if you subtract or add them, they give you this. So now let's check. For a number to be positive, so the first thing that we must see is that this is the difference. The difference of 6 and 3 is 3, meaning that they have to share different signs, these two. They have to be of different sign. But if this one is the more positive, it means that the 6 has to be positive here. Because let's check. Positive 6 minus 3 is what? Is positive 3. Negative 3 times positive 6, it gives you what? 18. Negative 18, which means that is correct because it gives you this and also gives you this minus plus. So this one will take the sign of this one, of the bigger number. It takes the sign of the bigger number. So now when we are done there factorizing, that's when now we are just going to find our x. But some of you might be asking, why are we finding 2x here? Why does it make sense? Because as we are just looking for the x here at d, and why are they 2x here? I will explain that why are they 2x, and it's very much important. It's very relevant when it comes to this answer here. So, but we must first see which x is relevant here. We have found negative 6. We have also found 3. So let's check which x is relevant here. The x which is relevant here is the x which is negative, because this side x is negative. So it's the negative 6 here. It also makes sense to say that this is negative 6. And then when it comes to what do we do with the 3 then? What do we do with the 3? The 3 is the other x coordinates where the graph intersects. Because here we are dealing with the points where the graph come together, or when the graph are equal. So the graph also come together here, which means that the x coordinate of here is going to be 3. And it makes sense because what? Because we see that it's before this 6 as an x variable. So it means that this is halfway between this 6 and also this. So this, but the one that we're needing is this 6. And then now we have found one variable. They said the coordinates. We have only found the x coordinate of d, which is what? Negative 6. How do we find the y coordinate? We take any of this equation and then we substitute that answer, the one that we found here, the one that we found of negative 6, and then it will give us the y coordinate. Let's choose this one. Let's substitute here and say 1x, or so 1 in the place of x we put negative 6, and then minus 6 is going to give us what? Negative 6 minus 6 is minus 12. So now it's telling us that it's minus 12 at y. Let's check here. So at y is minus 12. But what have we been learning since the beginning is that we must see whether it makes sense also in the graph. So if this is minus 12 here, it means that from here to here it's minus 6. It does make sense, because from here to here, from this coordinate is 6 also. So you see it makes sense that here it's minus 12. So they also make sense that we got that answer also in the graph that we have. And then when you continue, you see that 4.6, what kind of triangle is triangle ACO according to to the length of the sides, give a reason. So first you have to know the types of triangles. You have to know the type of triangles to say that there's a triangle where no sides are equal, and there's a triangle where, or if I rub like that, I'll also rub the answers that I think I'll also need. So let me also rub like this. So first we must know the type of triangles. The first triangle is a isosceles triangle, which has a, let me increase this so that you can see properly, which has opposite side, two sides are equal and angles are equal. The angle that corresponds to the sides are equal. So this is an isosceles triangle, and there is also an equilateral triangle. So this equilateral triangle, all the three sides are equal. So let's see what type of triangle they're talking about here. They're talking about triangle ACO. They want to know which type of triangle is it. How do we solve that? We solve that by checking the size of this, the sides of the sides of the triangle. So let's check the size of the sides. Yeah. So now let's check the triangle they are talking about. So they are talking about this triangle here. They said triangle. Let me check again. ACO. Okay. It start from ACO. There is the triangle we are looking for, and then this is the triangle ACO. Now let's see if any sides here of this triangle, they are actually sides which are equal. So now from here to here, the x is 6. It means it's 6 units. From here to here, y is 6 units. So we already have sides which are equal here. We have sides which are equal of this triangle, and then but now it means that it qualifies to be an isosceles triangle because two sides are equal. But let's get the sides of this. But here you can't count it like that simply because it is slanted. If it is slanted, we have to use it's either we can use Pythagoras. It can be very effective because the Cartesian plane is 90 degrees. So we can use Pythagoras and find this, or we can use the distance formula. But distance formula is just Pythagoras manipulated, man. It's just Pythagoras manipulated. But here we are just going to use a simple, let's use Pythagoras because Pythagoras will be simple here. So there's going to be r squared equals to a 6 squared plus 6 squared. We're going to see if this side will also be equals to 6. If this side is also equals to 6, it is all sides are equal. But if this side is not equal to 6, it means that therefore it's an isosceles because only two sides are equal. Because you can conclude that it's only an isosceles when we don't know the length of the other side. So we just come and say opposite square root 6. So it's going to be 36 plus 36 equals to r. So now what is the square root of 36 plus 36? So it's just 6 root 2. 6 root 2, it's also 8.48. 8.48, which doesn't give us 6. It means it's wrong. It's not wrong, but it means that it's not it's not a equilateral. This side is equals to 8.48, meaning that it's not equal to 6, meaning that it's isosceles because only two sides are equal to 6. So now we are going to write that what kind of a triangle is it. We are going to say it is an isosceles triangle. The reason will be what? The reason will be two sides are equal. Two sides are equal, and then you can just say equals to 6. It's up to you. And then yeah, you just showed that a method, the one that I showed there, and they said that without giving any calculation, give the what? Without any calculation, give the value of c. So let's go to this one and check. Let me rub here so that I can see clear. So now this is the last question. If you understood from here, if this was able to help you, consider subscribing and consider giving it a like so that I can push the content, so that I can bring more content like this. So now let's check at the angle which is being said here. angle C here. So angle C is this, and then they say we must do this without proving any calculation. Let me see this. Without any calculation, give the value of angle C. This one needs you to think deeply about this one. So one thing that it needs you to know in this is that angle C, it's where it's where this line here, it's where this line, this is gonna be equals to this, and this is gonna be equals to this. So this is what you have to know about this angle, and then it is talking about that you have to use this. And another thing that you have to know is that if you want to find an angle of inclination, of this, it's another calculation. They said without any calculation, but you will not show the calculation in the answer, but you can just use the gradient of this line. You can just use the gradient and say tan of the gradient. So if you check the gradient of this, so it's 1. What's puzzling me is that it's saying that we cannot use a calculator. So now it's gonna be m. It's gonna be tan of the m equals to the angle. So it's gonna be tan. Let me put it tan 1, because here we had gotten 1 is equals to the angle. So, and then shift tan 1. So it gives us 45 degrees. So it gives us 45 degrees. So, and then here I'll just come and say this is 45 degrees. Okay, yeah. Oh, I now get it. It's very much important that, oh, okay. Yeah, I shouldn't have used calculation now, but I just knew that if m equals to tan theta, it's gonna be like this, and then we just come and put the gradient here, and then the gradient will be equals to this angle is gonna be equals to shift tan theta, shift tan 1, and then after you get that, it's gonna give you 45 degrees. Shift tan 1 is gonna give you this answer. So now here the way that we are supposed to do it in a simple way, I now see it here, is because if this is 90 degrees here, this is 90 degrees, these two sides are what? Are equal, meaning that sum of angles of a triangle is what? It's 180. It means that it's 180 minus 90. You are left with 90. And then this 90 is divided by what? By equal angles. And then 90 divided by 2 is what? Is 45. So it means that angle C is 45. So that's the simple way of doing it. So our angle C is 45. So okay, thank you for staying around. This is future Dr. H numerics. See you in the next question. See you in the next video.